Here we're going to be looking at question 16 of the ENGAA 2018 paper. In this question, we're told we have a rock accelerating downwards. The question then tells us that the rock is experiencing a force due to air resistance of 12 newtons and that its acceleration is 2 meters per second squared. Finally, the question asks us, what is the mass of the rock? So, to answer this question, let's think about the information we've been given. Now we've been given a force and an acceleration. Straight away, this might make you think of Newton's second law. So, to try and see if we can apply that, let's go ahead and label all the forces we can onto our diagram. So, straight away, we know there's an air resistance force in the upwards direction of 12 newtons, and we know that in the downwards direction, there is the weight of the rock, which is going to be equal to its mass multiplied by the acceleration due to gravity. Now, we know that by Newton's second law, the total force on the rock is going to be equal to its mass multiplied by its acceleration in the downwards direction, our 2 meters per second squared. Then, by looking at our diagram, we can see that this total force is going to be equal to the weight of the rock minus the force due to air resistance. We know that the weight of our rock is equal to the mass of the rock multiplied by g, so we can substitute that in and then rearrange for our mass m. Plugging in our values for air resistance and acceleration, as well as the value of g which we're told in the question of being 10 meters per second squared, we find that the mass is equal to 1.5 kilograms. This then corresponds to answer C.